using the formula for the sum of an infinite geometric series. Determining whether the sum of an infinite geometric series is defined. If the terms of an infinite geometric series approach zero, the sum of an infinite geometric series can be defined. The terms in this series approach zero because you have 1 and then it goes to 0.2, which becomes to 0.04, 0.008, 0.0016. The common ratio, r is equal to 0.2, and as n gets very large, the values of r to the power of n get very small and approach 0. Each successive term affects the sum less than the preceding term. As each succeeding term gets closer to 0, the sum of the terms approaches a finite value. The terms of any infinite geometric series, with r being in between -1 and 1, but not including -1 and 1, approach 0. The sum of the geometric series is defined when r is in between -1 and 1, but does not include -1 and 1. Now, determining whether the sum of an infinite geometric series is defined. The sum of an infinite series is defined if the series is geometric and r is in between -1 and 1 and not including those. So again, it has to be geometric and in between -1 and 1 and not including -1 and 1. So, given the first several terms of an infinite series, determine if the sum of the series exists. Step 1, we want to find the ratio of the second term to the first term, and then find the ratio of the third term to the second term, and then continue this process to ensure the ratio of a term to the preceding term is constant throughout. If so, then the series is geometric. Now, once we've determined it's geometric, now if a common ratio r was found in step 3, we need to check to see if it's in between -1 and 1. And if so, then we can say the sum is defined. If not, the sum is not defined. So for example 6, we're determining whether the sum of an infinite series is defined. So for the first one, we have 12 plus 8 plus 4. Now, the ratio of the second term to the first term is 2/3, because 8 divided by 12 reduces to 2/3. Now, if we take a look at the next one, 4 over 8, it is 1/2. And so therefore, we can see that the ratio of the second term to the first is 2/3, which is not the same as the ratio of the third term to the second, 1/2. Therefore, the series is not geometric, and it would not be defined. Let's take a look at B. We have 3/4 plus 1/2 plus 1/3. If we take 1/2 and divide it by 3/4, so we have 1/2 divided by 3/4, which is the same thing as 1/2 times the reciprocal of 3/4, which is 4 over 3, which is equal to 2/3. If we take 1/3 and then divide 1/2, if we take the reciprocal, it becomes 1/3 times 2 over 1, which is equal to 2/3. And therefore, we can see that since those two are the same, then we can say that this so far is a geometric series. So the ratio of the second term to the first is the same as the ratio of the third term to the second. The series is geometric with a common ratio of 2/3. Now the common ratio of 2/3, in order for it to be defined, has to be in between -1 and 1. Well, 2/3 is a fraction which is less than -1, is greater than -1, but less than +1. Therefore, the sum of the infinite series is defined. Let's take a look at C. So we have the formula 27 times 1/3 to the power of k, and k is equal to 1 is the lower limit going to infinity. Now, if we take a look at 1/3, that represents the ratio. The ratio is equal to 1/3, and therefore 1/3 is in between -1 and 1. So the given formula is exponential with a base of 1/3, and since it's an exponential with a base of 1/3, then we can say that the series is geometric, and it has a common ratio of 1/3. And so therefore the sum of the infinite series is defined. Let's take a look at part D. The formula is 5k. K is equal 1 to infinity. Now, if you take a look at this formula, it's not exponential. The given formula is not exponential, and therefore the series is not geometric because the terms are increasing and so cannot yield a finite sum.